There's a telescope in Chile that does not sleep. Every night, high in the Atacama Desert, it opens the largest digital camera ever built and stares into the dark. But it does not look at the universe the way other telescopes do. It does not choose one galaxy and study it for weeks. It does not wait for one perfect image. It does not capture space as a frozen picture. It watches everything again and again. Every 3 nights, the Vera Rubin Observatory scans the visible southern sky, searching for anything that moved, brightened, vanished, exploded, or appeared where nothing was supposed to be. And in its first months, before its full mission had even truly begun, it started finding things that should not have been there. A single image containing 10 million galaxies, a river of stars stretching 163,000 light-years from a spiral galaxy, more than 11,000 newly discovered asteroids, a spinning object so large and rotating so fast that physics says it should have torn itself apart, a star in Andromeda that may have collapsed directly into darkness, and objects from other star systems, passing silently through ours like visitors from places we will never reach. Rubin was built to map the universe, but what it captured first was something far more disturbing, proof that the sky is changing faster than we can understand it. The Vera Rubin Observatory sits on a mountain in Chile beneath some of the driest and darkest skies on Earth. Its mission is called the Legacy Survey of Space and Time. That name sounds calm, almost academic, but what it really means is this. Rubin is building a 10-year movie of the universe. Not a picture, but a movie. Every few nights, it scans the entire visible sky from the southern hemisphere. Then it compares the new image with the last one. If something has changed, Rubin notices. A dot moved, a star dimmed, a galaxy flared, an asteroid appeared, or something vanished. Each change becomes an alert. When Rubin's alert system was tested, it produced hundreds of thousands of alerts in a single night. Eventually, the observatory is expected to generate millions of alerts every night, each one pointing to something in the sky that is different from before. This is what makes Rubin unlike almost every telescope humanity has ever built. Hubble changed astronomy by showing U.S. detail. James Webb changed astronomy by showing us infrared light from the ancient universe. But Rubin is different. Rubin changes astronomy by giving the sky memory. For thousands of years, humans looked up and saw patterns. Stars seemed fixed. Constellations appeared eternal. Galaxies looked distant and silent. The universe felt slow, almost frozen. But Rubin is revealing that this was an illusion. The sky is alive with motion. Asteroids cross the solar system. Stars explode. Black holes may form without warning. Objects from other star systems enter and leave. Galaxies stretch, tear, merge, and reveal structures too faint for older surveys to see. And because Rubin keeps returning to the same places, it can detect changes that no single image could ever reveal. This is the new frontier, not just deep space, but changing space. And the first results already showed how much we had been missing. On June 23, 2025, the world saw the first images from Rubin, and one of them was almost impossible to process. A single composite image of the Virgo cluster contained around 10 million galaxies. 10 million galaxies, not stars, galaxies, each one potentially holding billions of stars, planets, black holes, nebulae, and unknown worlds. And this was just one image covering only a tiny fraction of what Rubin will eventually photograph. If you tried to look at every galaxy in that one image for only 1 second each, without stopping, without sleeping, and without blinking through the task, it would take you months. And yet, for Rubin, that was only the beginning. The telescope is expected to observe billions of galaxies over its decade-long survey, creating one of the most complete maps of the universe ever assembled. But buried inside those early images was something more unexpected. A stellar stream, a river of stars being pulled away from the spiral galaxy Messier 61. It stretched 163,000 light-years. That is larger than the diameter of the Milky Way, and no one knew it was there. This is one of the reasons Rubin is so powerful. It does not only detect bright, obvious objects. It can reveal faint structures spread across enormous areas of sky. Structures too wide, too dim, or too subtle for other telescopes to easily capture. A stellar stream is not just a beautiful feature. It is evidence of violence, It means gravity is tearing a system apart. A smaller galaxy or star cluster may have passed too close to a larger galaxy, and now its stars are being stretched into a long cosmic river. These streams are the fossil trails of galactic destruction. They show how galaxies grow, how they devour smaller systems, how invisible dark matter shapes the motion of stars, and how the universe builds large structures through collision, gravity, and time. Rubin captured one that had been hiding in plain sight, a structure larger than our galaxy, invisible until the right instrument looked with enough width, enough sensitivity, and enough patience. And that was only one of the first surprises. Before its full mission even began, Rubin discovered more than 11,000 new asteroids. That alone would be historic. But it is only a preview. Scientists expect Rubin to discover around 1 million previously unknown asteroids in its first year of full operation, roughly equal to the number humanity has cataloged over the previous 2 centuries. In 12 months, Rubin could double centuries of asteroid discovery. That matters because asteroids are not just rocks. They are remnants of the early solar system. They carry records of planetary formation, collisions, migration, and the violent history of the space around Earth. Some are harmless. Some cross near our planet. Some may become important for future missions, and some are strange enough to challenge what we think we know. One of them is called 2025MN45. It is enormous, almost twice the height of the Empire State Building. But its size is not what makes it so disturbing. Its rotation is. This object is spinning once every 1 minute and 53 seconds. For something that large, that is extremely fast. Fast enough that centrifugal force should be pulling it apart.